So as a warm-up, as I was going around checking homework a while ago, I asked you to do these patterns here. And so we're going to talk through this. Our next unit that we're beginning today, again, this homework's not due till Wednesday, all right, because I want you to kind of focus on the test or whatever tonight. But this sequence and series idea, it's very formula-driven, and the formulas are on your formula page, okay? It's very formula-driven, and the formulas are on there. Now, the other thing about it is this. These type of questions, the SAT and the PSAT like to ask these questions, all right? So you'll probably see that pretty soon on some of your PSAT and SAT stuff that you're taking. But on those tests, you normally don't get a formula sheet. So it's good to kind of understand it and so forth, okay? Now, what is the number that you put in the blank on the red one? 17, okay? 17 goes in the blank there. And what was the pattern? Minus 2, minus 2, minus 2, minus 2. So here's the thing. Anytime that you are adding or subtracting, if you're adding or subtracting to get to the next number, it's called arithmetic. Okay? Arithmetic sequences and series are when we're adding or subtracting to get from one to the next. The green one. What's the number? 32. And what's the pattern or what's the process? We're timesing by 2. We're multiplying. All right? Anytime that you multiply to get from one to the next, we refer to that as geometric. So if I multiply to get from one term to the next term, all right, it's geometric. Now, I should clarify this. I have to add or subtract or multiply by the same number. So this is the same number over and over again. This is the same number over and over again that we're multiplying by. Okay? Question 8, or not 8. Question, the blue one up here. All right? What goes the blank? 8. I was getting ahead of myself. Sorry. Gave a freebie there. All right? How is it 8? What are we doing? What's the pattern?
You're adding the previous two numbers together.
Okay, you're adding the previous two numbers together. So 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 3 is 5. Anybody seen this pattern before? Yes, what is it? Fibonacci sequence, okay? Fibonacci was a famous mathematician that did a lot of things with some art and some sequences and going ratio, all right? We refer to this type of sequence as recursive. Okay? We refer to that one as a recursive. What that means is that we're having to use the term before or maybe two terms before to get this answer. Okay? And so I'm using the previous ones and I'm continuing that one. Okay? All right. How about the one in the black down here? 25? Okay. How did you get 25? The what? The squares. Okay. So this is the first term, and I'm going to square it. This is the second term, and I square it. That's the third term, I square it. So I can do it that way. Did anybody get 25 a different way? Yeah. Yes, sir?
So I saw it as there was just an increasing amount that you added to each number. So
Okay.
from 1 to 4, you'd add 3, 4 to 9 is 5, 9 to 16, 7, and then after that you just do 9.
Good. So we're adding odd numbers, and we're increasing the odd numbers as we're going. So we add 3, then add 5, then add 7. Now, add 3, add 5, add 7, add 9. Is that arithmetic? No, because it's not the same number. I can get there by adding, but it's a different kind of a pattern. This one would fall in the category of other. All right, we don't really have one there. It's just they might ask you to do something like that. Okay? Today our focus is going to be on arithmetic. That's where we're going to look to start. Okay? All right. On your formula page, this is the formula for arithmetic sequence. Okay? You have this in the little blue formula sheet that I gave you. Got several little side conversations going on. Let's focus in. All right. First of all, when you look at this, you're going, where are all the numbers? All right. So let's identify kind of what's taking place. All right, U1. U1 is the first term. Okay? U1 is the first term. D stands for the common difference. Okay? So the D value stands for the common difference. That's what I'm using to get from one term to the next. A while ago on that red problem, we were subtracting 2 each time. -2 would be my common difference. Okay? Now, the last two variables in this one are a little bit tricky. I'm going to write them out and then we'll talk about them. UN is the nth term, is how we refer to that. And then N is the term number. Okay? So UN is the nth term, and N is the term number. So if I was doing this right here, if I had a sequence or whatever, and I was looking at this number right here, all right? This is term number N, and UN would be the number that's in the blank, all right? So if that was 3, this would be term number 3, and N would be 3, and whatever number is in that third blank is my UN. So the N is the position that I'm in, the UN is the actual number that's in the blank. Everybody okay with that? N is the position, and UN is the actual number that's in the blank. That's the difference between the two. All right? Now, how do I find my common difference? A lot of times with common difference, we're going to be able to look at it and see it. But if I'm struggling with to find it, I'm going to take U to the N plus 1. What do you think UN plus 1 means? The next number, okay? So I'm going to take this number right here, that's U to the N plus 1, and I'm going to subtract the previous number from it. So minus UN. So if this is UN, then this would be UN plus 1. That would be UN plus 2 if you wanted to do that. But I'm going to take this one minus that one. Or if I knew this one, I could subtract it from the one in front of it. So that's what I'm doing. I'm taking a number and subtracting the one before it from it. That's how I find my common difference. Okay? That's what it's saying right here. Okay? We'll have some practice on that on the next one here. Everybody okay so far? I know some of you are going, where are the numbers? You're ready for the numbers. All right. Here we go. Let's take a look. Give you a chance to copy this sequence down. So the sequence I have is 2, -3, -8, -13. 2, -3, -8, and -13. Now, if I ask this question right here, what is the common difference? You would say -5, okay? Now, the only thing different about this is it says show that. It doesn't tell me that it's arithmetic, correct? It's telling me to show that it's arithmetic. So I need to do a little bit of proof. So what I'm going to do is I'm going to take 3 and I'm going to subtract the number in front of it. So the D value, the common difference, is going to be -3 minus 2, which gives me -5. If I wanted to prove some more, -8 minus 3, -8 minus a -3, that's also -5. Have I proved that it's arithmetic now? What if I showed that it's the same number at least twice in a row, correct? And then I could do that again. I could go -13 minus a -8, and that would give me -5. So because it's the same number over and over again, I've shown that it's arithmetic. Everybody okay with that reasoning? That's different than if they said, what's the common difference? And you just tell them it's -5. Okay? Everybody good? Now, this next one right here really bothers a lot of people. This question bothers a lot of people. It says, find the general term. So general term is the main thing that they're asking for here. Find the general term. All right? So here is my formula. UN equals U1 plus D times N minus 1. So that was the formula that we discussed on the previous page. What do you know in that formula right now? We know the D, we just found it, and we know what? Somebody said it.
The term?
Which term? The
Term.
first term. We know the first term, which is 2, and we know the common difference, which is -5. All right? So what I have right here is my general term. I put the first term in, I put my common difference in, and now that right there is referred to as the general term. Now here's why. If you know where to start and you know how to move, could you get any number in this sequence? You can, right? You tell me where you want to be. I want to be at the 100th term. Well, I can go find it. Okay? You tell me that term, this certain term is part of this. What term number is it? I can go find it. As long as you have the first term and how to move, which is my common difference, then that's my general term, and I can do any problem you ask me to do from now on. Okay? That's my general term right there. Now, let's look at part C. Part C says find the 100th term. Now, before we get there, let me ask this question. What's the 10th term? If you weren't using the formula, could you write the 10 terms out? Would that be a way you could do this? Absolutely, right? Now, if I ask you to find the 100th term, could you write all 100 numbers out? You could. I don't know how efficient that would be. Remember, this is a time test, and we want to be a little bit more efficient with it. So, yes, you could write all 100 out if you needed to. All right, that's fine. But I don't know that that's the most efficient way. So on this, what does 100 mean in the context of my problem? That is my N. That is my N. That's the position. So I'm going to go UN equals 2 minus 5 times N, which is 100, minus 1. Okay? And I'm going to work that. 100 minus 1 is 99. 99 times -5 is -495. Got the 2 out front, that's positive. So if I drew out 100 blanks of this, the number -493 would be what would be in the 100th blank. Okay? I don't know that I want to draw all those out. So this is a pretty fast, easy way to do that. Okay? Now, question D is just the opposite. It's asking, is 323 a member of the sequence? So what's 323?
UN.
That's UN. Now, before we plug it in, thoughts about 323. Is it a member of the sequence? Yes or no? Think it is?
How are we supposed to know that?
How are we supposed to know that?
We do the opposite.
Here's what I'm thinking. What positive numbers do I have? 2, and then where does it go? All the negatives, right? So is this possible for it to be a member sequence? No. I think there was a typo when I wrote this question. I think it's supposed to be a negative 323. Now does it have a chance at least?
Yes.
Now it has a chance. Okay? Now, so let's do this. I'm going to put, this is the number that's going in the blank. So I'm going to put it in for UN. So I'm going to go -323 equals 2 minus 5. And what I'm solving for, if it's part of the sequence, then I want to know what blank it goes in. I want to know the N. Okay? Now be careful with this. Please do not put the 2 and the -5 together. They don't go together. All right? I would probably get rid of the 2 first. So I'd -2 on both sides. So I get -325 equals -5 n minus 1. Now some of you right now are going, Coach, why didn't you just distribute and combine like terms? Could I have done that? Sure. All right. Some of you are going to distribute right now. I'm just going to divide by the -5. That's fine as well. So I'm going to divide by -5. Negative over negative is positive. That is 65 is what that is. And it's n minus 1, so I'm going to add 1. So the answer I get is I get this. What does that mean? It is the 66th term. So is negative 323 part of the sequence? Yes. Okay? How would you know if it's not part of the sequence? If you got a decimal, you got a fraction, right? Because this n number is the placement, it's the position, which has to be a whole number, okay? You don't hear anybody say, I got 12.5 place. That doesn't make any sense, all right? You got 12th place, you got 3rd place. Say again? Now, if it was a negative, what would that mean? Then I went backwards in time. So I probably don't really want to do that. And I don't really want a negative either. So, because I'm starting at a certain location, and I'm not really going negative. Although we could probably extend that pattern backwards, right? But they're saying it starts here and goes forward. Okay? If you got a negative, I would say no, that's not right. Okay? All right? Everybody good there? All right, let's go to next. Give me a chance to copy this one down. All right. It asks me to find K, given that I have 3K plus 1, K, and -3 are consecutive terms of arithmetic sequence. So that's kind of weird. That's kind of funny how it's written. I like to draw the picture of it. So if I draw the picture of this, this is one term. So 3K plus 1 goes in that blank. K goes in that blank. -3 goes in that blank. So that's kind of the picture. If I'm looking at it in picture terms, that's my picture. Okay? Now, it asks me to solve. The nice thing about this is it does tell me that it's arithmetic. Which means what? Yeah. I'm going to add or subtract the common difference. I'm going to add or subtract the common difference. And that's how I'm going to get from one to the next. Okay? How do you find the common difference? Did on the page a while ago, or showed you a formula on the page a while ago. You take the second minus the first. Or you take the third minus the second, or the fourth minus the third. You take a number and you subtract the number in front of it. That's how you find the common difference. So to find the common difference, I could say K minus 3K plus 1. That would find my common difference. Okay? Or, some of you are going, I'm not doing that one. Some of you are going to go, well, I could do -3 minus K. That would be my common difference. Now, what do you notice about these two? Or what do we know about these two? If it's arithmetic, what's true about this common difference and that common difference? They're the same. So these two things are actually equal to each other. So I could set those two things. I could set K minus 3K plus 1 equal to -3 minus K. And I'm going to go solve that. So I'm going to go on and distribute. So K minus 3K minus 1 equals -3 minus K. I'd probably add 1 here, add 1 there, so that I can move this K to this other side. So I'll move the K's over, I'll move everything else to the right. That 1 cancels, that K cancels. So -3 minus, or -3 plus 2 plus 1 is -2. Sorry. K plus K is 2K minus 3K is -2K. Try negative just K. Struggling right now, sorry, my apologies. Alright, 2 minus 3 is -1. Negative K equals -2. And so K would equal to 2. Okay? Now I did what it said, right? I solved for K. But some of you still got this puzzled look on your face, and like that's a little bit weird as well. So if I take the K and I go plug it back in, if I take K and plug it back in, I can plug it in there, so that would be 2. This would be -3. If I put the 2 into this one, what do I get? 7. Is that an arithmetic sequence?
Yeah.
-5, -5, so it looks like it works. The other thing is this, take the 2 and plug it in here. What's -3 minus 2? -5, because that was a common difference equation a while ago. You could plug it in here too and you'd get -5 as well, all right? And so I like it once I plug it back in, I see the actual numbers, I can see, okay, yeah, did I do it right or did I mess something up? I need to go back and check my work, okay? Everybody all right with that one?
Yeah.
It's a little bit abstract. Yes, ma'am?
When you put the K minus 3K, what did we get rid of?
They get rid of this 3 right here,
No, the line.
this one here. So I got 2K minus 3K would be a -1K. Okay? So all that is combining like terms right there. Combine all those together. Okay? Good? Anybody else? All right. Take a look at this one. I want you to see if you can draw me the little, draw me a picture of this real quick. Give you a chance to read it and draw a picture.
You'll just stop, please stop. Stop copying.
Got a new term, arithmetic means. So if you have arithmetic means, right, that's the numbers that are in between two numbers. So in this case, it says to insert 3 arithmetic means between the number 9 and between the number 29. So I have number 9 here. I'm going to insert 3 arithmetic means, and then I have the number 29. Okay? So there's the picture that I'm being asked to do. Okay? Any thoughts on how we could start this by plugging in the arithmetic means? Yes, sir?
You can find the average of 9 and 29. and
Okay.
put it in the middle.
You could find the average of that. Yeah, you can, because that is talking about means. All right? Now, I'm going to do something else with 9 and 29. That's the difference that I'm going the whole time, right? And so I'm going to go 9 minus 29, and I'm going to get 20. So there's a 20 difference from 9 to 29. What am I going to do with that 20?
Divided by the number 5.
Divided by how many?
By 3.
By 3? By 4? Okay? Here's what I would do. Drawing the picture helps. If this is arithmetic, then it takes a common difference to get from there to there. It takes another common difference to get from there to there. It takes another common difference to there, and one more common difference to get there. So it takes 4 common differences to get through the problem. So I'm going to divide this by 4, not by 3. So be careful. I see 3 blanks, but it's actually 4 steps that I'm taking. Which means each step is what? 5. So 19 plus 5 is 14. 14 plus 5 is 19. 19 plus 5 is 24. And then one more 5 is the 29. Okay? That's one way you can do that. Some of us like to think logically through it and like to do it that way. Perfectly fine. You've shown me some work. I'll take that work or I got it. Now, there's another way to do this. Here's the formula that we talked about a couple minutes ago. Yep. What information do you know here? Just using the green that we had, just using the 9 and the 29. All right? Let's assume that we don't know what the common difference is right now because we just started this problem. All right? What information can I take from that and plug into the equation? The first term. The first term's 9. What else do I know? I know the last term. What term number is that in this one? It's term 5. In this case right here, 29 would be U5. It's the 5th term. Okay? So I could put 29 in here, I don't know my D value. I know my term number. My term number is 5 minus 1. So I know a lot of the things that are in my equation already. Well, how would you solve this? Well, I have minus 9 to start. Well, does that look familiar? Okay. Equals 5 minus 1 is 4 times D is 4D. I would divide by 4. So now I've got my common difference of 5 like I did that way. One of them I just kind of drew a picture and thought intuitively about it. The other one I had my formula and I plugged into my formula and I can go get it from that way. Do I care which way you do it? I do not. But you do have to show your work. You have to show how you got there. Yep. All right. One last thing real quick. All right. I'm going to start this one, but we're not going to get really far on it. All right. This is UN equals U1. I've got R to n minus 1. Okay? All right. This is your geometric formula, is what this one is. So we talked about arithmetic a while ago. This is your geometric formula. And if we look through it, U1 is still my first term. UN is still my nth term. N is still my term number. And the thing that is different in this problem is the R. Okay? Everything else looks like the same. By the way, what type of equation does this look like? Exponential. Why? Because with geometric, we're multiplying and multiplying and multiplying, so we're repeating multiplication, which is an exponent. Okay? What does the R stand for? Anybody got a thought? Rate, that's close. It's the ratio. Okay? This is the common ratio. All right? So in a geometric, when we're multiplying by a common ratio, not a common difference. Okay? To find the R value, you would take the term number n plus 1 and you divide it by n. So you're going to take this one and divide by the one in front of it. So if this was 8 and that was 4, then we would do 8 divided by 4. That's how we would do it. So take the second one, divide by the first. Or take the third, divided by the second. Okay? All right, we're going to end there today. All right, page 8, 15, and 16, that's not due till Wednesday. All right? Just real quickly, as you look at this, a lot of the arithmetic stuff will be kind of non-calculator. The geometric things are probably more the calculator things. They're the ones that get numbers a little bit bigger, a little quicker. Okay?